ribosomal, messenger, and the tRNA. Now, out of this RNA, the messenger RNA, that will undergo translation process. Now, the product of translation is the production of polypeptide, which is an immature and non-functional protein. And this polypeptide will undergo maturation process. So this has to undergo maturation process, maybe in the Golgi apparatus for the secretory proteins, and to become functional protein. And this is now the protein which is needed for metabolic processes. Okay? So, what is this messenger RNA for? You have the word messenger. Messenger, this is the one, the information coded in this messenger RNA, of course, that comes from the DNA. The DNA's genetic information would be transferred to or copied in the mRNA. So that will be translated into a polypeptide later on to protein. How about this rRNA? Now, ribosomal RNA is for the formation of ribosome. Because ribosome, which is the site for protein synthesis, that is where protein is synthesized in the cytoplasm. So here, there are lots of ribosomes here in the cytoplasm. And that comprises the rRNA and proteins. So that is where translation occurs, or expression. Say, the full expression would be held at, say, or during translation process at ribosome. Now, tRNA, so you have tRNA or transfer RNA. You have this structure. So why is it's called tRNA? Because it looks like T. Now, it has these important structures. Of course, these are the genetic informations coded from the DNA template. Now, we have this so-called anticodon loop. Now, this anticodon loop fits, or it is said to be the opposite or fits with the codon of the messenger RNA. So, for example, if the codon of the mRNA is CCG, so this is the mRNA. Now, this is now the codon. Now, how about for tRNA, which is anticodon? Anti means opposite. Okay, so this is GGC. So that is GGC. So here, it's found in the anticodon loop. Opposite to that is the amino acid attachment site. So, whatever is this, what is this codon? CCG stands for. CCG, we have here mga tables. I-forward na natin sa ato ang group chat. CCG stands for proline. So it's here. CCG stands for proline. Are you with me? Tanawan ninyo yung sa group chat na i-forward na po. CCG stands for proline. It's the amino acid proline. So, kani siya diri, this is for proline. Okay. So, the anticodon fits with the codon in the mRNA. Okay? So, what else? So, we will start right away with the DNA replication. Any question? Okay. Okay. Now, DNA replication. Okay, when is the, as to what stage in the cell cycle where DNA replication occurs? What stage in the cell cycle?
Anaphase.
Okay, anaphase is part of the M phase, which is the dividing phase. So you have the interphase period, which is subdivided into three major phases. You have the G1, the S phase, and the G2. So as to what particular stage where DNA replication occurs, where there is what they call as doubling of the genetic material of the DNA. Say, if this is our cell cycle, this is the M phase, which is a very short period only. This is M phase. Now, the whole thing here is the interphase period, meaning most of the time the cell is in the interphase period. Now here, this is subdivided into three major phases. You have the G1, or the gap 1, the S phase, and the G2, or the gap 2. So when the cell divides, or after cell division, the cell passes through the G1, or the growth 1, growth period, and prior to G2, the cell would pass through the S phase, or the synthesis phase. And this is the time where DNA replicates. So, ang isa ka DNA, one DNA molecule becomes two DNA molecules. So, there is the time where the chromatids are said to be doubled. What's the purpose of doubling this genetic material? That is, of course, in preparation for cell division, another set of cell division. So, ang isa ka DNA, imong duha. Remember, when the cell divides, ang isa ka cell, ang mother cell becomes two. That is during mitosis. One cell becomes two. So, dapat madoble ang genetic material. Ang mother cell, ang mother DNA, mahimong buha. That's why there are two sister chromatids as the result of S phase prior to another set of cell division. Okay. Now, this is the structure of ribosome. The structure of ribosome. Now, the ribosome is made up of two subunits. Now, what is the role of ribosome again? This is the site for protein synthesis. Now, we have the larger subunit and the smaller subunit. Now, this is very, very important during translation process. Okay, we say gene. Gene is the part of the DNA that codes for a protein. Now, DNA is very long, as what I have said, class. But only 10% is said to be expressed into protein. The rest will be non-coding sequences. Now, we may call that as introns. So, that introns are they cannot be coded into amino acids. Non-coding sequences. Now, if they cannot be translated into protein, the 90% of the whole length of the DNA cannot be translated into protein. Why is it that the designer or God made a very long DNA? Where in fact, only 10% can be translated into protein. What is that 90% for? What do you think? What's the purpose of God? Why? He made DNA very, very long, and yet only 10% would be translated into protein. The rest are non-coding sequences. They are called mga introns. Non-coding sequences. And they will not participate in the translation process. Okay, what do you think? Any guess? Any guess?
Each organism has a specific code, and the remaining the code for a specific organism.
Yeah, each organism has its specific code. Because we have our own sets of DNA. I mean, we have our own DNA said to be transmitted from our parents. And we are said to be unique from the rest of our siblings. No? Except for our identical twins. But why is it that DNA is said to be very long? Well, in fact, only 10% can be translated into protein. 10% of that is coding sequences. The rest, na 90% will be non-coding sequences. They have to be cut off prior to the translation process. What's the purpose? Any guess? Ano kinahanglan ng patasoy nga di man day naggamiton? What's the possible use of that non-coding sequences or 90% of that DNA length? What do you think? Yes.
For splicing.
For splicing, yes, they have to be spliced because they are not needed, meaning they have to be cut off because they are not needed. But why is it that if they are destined to be cut off, why is it that the DNA must be composed of this say portion which are said to be destined for splicing or cut off? What do you think? Any guess? Now say for example, to give you an idea. Now say, if this is your DNA, ay radiation. Niagi. Okay? So, your cells are exposed to radiation. Okay? Alpha, beta, gamma, radiation. Or say, exposed kag mga chemicals which are said to be mutagenic or carcinogenic, cancer-causing, like sibukaon, hotdog, beef loaf, corned beef, mga sa kalanin ha, deep fried, yung mga kuhan, sibukaon, and then, diha nakabind sa non-coding sequences because 90% is non-coding sequences.